Every single time you stream a movie, post a photo, or jump on a video call, you're tapping into this huge, invisible network of machines. But have you ever stopped to think about what actually powers that network? Well, in this explainer, we're diving into some really fascinating research that looks at how we can feed our digital hunger with our own trash.
It's a question we almost never ask ourselves, right? Our digital lives, they feel so clean, so weightless. But behind that screen, there's a massive physical infrastructure with a very real and honestly, a rapidly growing environmental footprint. See, the cloud isn't floating up in the sky. It's in a building somewhere, and that building is incredibly thirsty for power.
And just how thirsty are we talking? Well, the numbers are pretty staggering. A study in the journal Energies found that data centers in the EU use nearly 100 terawatt-hours back in 2022. But look at this. By 2026, it's projected to jump all the way to 150. That's a 50% increase in just 4 years. So yeah, finding reliable green energy isn't just a nice idea anymore, it's absolutely critical. So that brings us to the core problem here. This massive and just constantly growing demand for electricity from these digital engines that, let's face it, we all depend on now. The real question is, how on earth do we power them sustainably?
Now, when we think green energy, our minds usually jump straight to solar panels or those giant wind turbines, and those are great. But data centers, they have a special need, a requirement that those sources can't always meet.
Here's the thing. Data centers can never, ever shut down. They need a constant, totally uninterrupted flow of power, 24/7. Solar is amazing when the sun's out, and wind is fantastic when it's windy, but they're both dependent on the weather. Biomass, on the other hand, it can provide a steady, reliable stream of energy, day or night. So what is it exactly?
To put it really simply, biomass energy is basically a way of turning waste into power. We're talking about organic stuff, like agricultural waste from farms, or even wastewater. This material gets converted into something called biogas, which then generates both electricity and heat. It's renewable, and, hey, it also helps communities deal with their waste.
And this is where the whole idea gets really elegant. It's not just about swapping one power source for another, it's about creating this incredible symbiotic relationship, a closed loop, you could say, where the data center actually becomes part of a local circular energy system.
Check out this wild fact. Almost all the electricity a data center sucks in, we're talking nearly 99% of it, is converted directly into waste heat. Those servers get really hot. Now that heat is a massive waste product for sure, but it's also a huge opportunity. Okay, so let's walk through how this whole cycle actually works. You've got organic waste going into a biogas plant. That plant generates steady green electricity for the data center. But then, and this is the genius part, the waste heat from all those servers is captured, and it can be fed right back into the system, maybe to help with cooling or other processes. It's a perfect loop where one process's waste becomes another's fuel. This quote from the study just nails it. It's all about changing how we see these buildings. Instead of just being giant energy hogs plugged into the grid, data centers can become active, contributing partners in a local energy ecosystem. But you might be wondering, is this all just theory? Not at all. In fact, let's take a look at a real-world project planned in Mykolaiv, Poland, that's designed from the ground up around this exact concept. This facility is being designed as a complete, holistic system. It's powered by local biogas and solar, sure, but it goes way further than that. It integrates what they call green infrastructure. We're talking planted areas, green roofs, which actually helps regulate the building's temperature naturally. And get this, that same greenery produces its own biomass that can be fed right back into the energy system. It's a truly full-circle design. Okay, this all sounds pretty incredible, right? Which, of course, brings up the obvious question, if this model is so effective, why aren't we seeing it everywhere? Well, the study points out a few key barriers. For one, things like green roofs and living walls are often treated like optional, cosmetic add-ons, not core parts of the design. Then you've got regulatory hurdles that can slow these projects down. And, crucially, there's often a total lack of planning that connects the dots between the energy systems and the landscape design from day one. So even a lot of data centers that call themselves sustainable aren't using this kind of deeply integrated approach. So all of this brings us to what's probably the most important takeaway from this whole study. It's really about a fundamental shift in how we think about and how we plan these essential pieces of our digital world. When you boil it all down, the research makes one thing crystal clear. For a data center to be truly green, things like biomass energy and integrated green design can't be an afterthought. They just can't. They have to be treated as core, non-negotiable elements right from the blueprint stage,
from the very, very beginning of any new project.
And that kind of leaves us with a final thought to chew on. We tend to think of data centers as these hidden away boxes, silently consuming tons of power. But what if they could step out of the shadows? What if they could become visible, active partners in building a more sustainable, a more circular future for all of our communities? What if the cloud could actually help green the ground?